Alright everyone, my name is Chiranjeevi and I am back with one more structural design pattern which is called the facade design pattern. And to explain this pattern, we will first take a look at the problem it is trying to solve. But yeah, here's I have put a very nice image of a little castle over here which will actually represent the meaning of this facade pattern. So let's quickly take a look at the definition and then we will try to relate it why uh, and how facade pattern works. So facade is a structural design pattern that lets you provide a simplified interface to a complex subsystem of classes, library, or a framework. So let's say you have a system in which you are doing so many things and you have so many state to maintain in the system and you do not want to expose the internals of the system to the world, but you do want the world to use your system, and at the same time you don't want to expose the internals of your subsystem to the world. So the way you expose your subsystem to the outside world, what you will do is you will expose an interface which will be our facade, and that interface will only support those functions or operations what you want to expose for the subsystem. So this is what the definition is trying to say. Let's say you have a very complex system of classes or a library, but you actually don't want to expose the internals of your library, right? So what you will do is expose an interface which will actually perform the operations for you, which the library will be performing underlying without exposing the internals for the library. So that's what the facade pattern is for. It's a structural design pattern which lets you provide a simplified interface to a complex system of classes. So we have discussed the problem. Let's jump right over to the UML diagram. So here we have a small subsystem of shapes, and what all the shapes allow is you can actually draw them. So we have an abstract shape class and we have three extensions for this shape. We have circle, rectangle, and a square, and all of them provide one draw method which is being overridden in the respective subclass. Now we don't want to expose the internals of this shape subsystem. What we will do is we will create an interface which will actually talk to our shape subsystem, and this interface will expose only those methods which we want to support. So let's say you have one more shape called triangle, but it is still in the testing phase and you don't want the user of this subsystem to actually be able to create triangles. But the only way to restrict them is to restrict access to the subsystem itself. So here the shape maker, which is acting like a facade, will actually provide only those methods which you want to implement. So since there will be no draw triangle method in your facade, no user using this facade will be able to talk to your subsystem and will able to request you to draw a triangle. And that's it. What you do is you expose a set of methods what you want to support for your subsystem without allowing the client to actually interfere with the internals of the subsystem. So that's it with the UML diagram. Let's actually have a look at the running example. So we will try to map our UML diagram with the code example. Here we have a shape subsystem which represents this abstract class, and it has a draw method which does not return anything, it simply draws. And we have three implementations for this shape, which is circle, rectangle, and a square. And all these circle, rectangle, and square do is override this draw method and provide their respective implementations for the shape. Now let's go to our shape maker class and we'll see how this shape maker is actually letting this main client draw these different kinds of shapes without letting it access the internals of the subsystem. Oh, this is our shape maker facade, and you see it has a reference to all your private shape subsystem classes. It has circle and rectangle and a square, all which is private to this facade only. When you instantiate this facade will request the creation of all the relevant subsystem objects which you want to deal with. Now we have provided three different methods, which is draw circle, draw rectangle, and draw square, which we have provided over here. And all this is doing is calling the draw method for the respective class. Now let's say your shape system has one more class called triangle. But if you don't provide an implementation or a way to actually create or draw a triangle here, this client will not be able to actually draw the triangle. So whenever you want to use this shape subsystem, you will talk to your shape subsystem using this facade. You will instantiate a facade object and you will ask the facade to do the logic for you. So that's it with the coding example. Since it was a very small example, I preferred it not to actually code it in a live way and actually pre-code it and actually show you the example how it works. So that's with the facade pattern. If you have any doubts, you can ask it in the comments. Otherwise, I'll see you in the next one.